When most people think about PKI, they think about certificates and configuration details. In this course, we'll step back and treat PKI as a core trust layer for your entire organization. Every design choice you make about keys, certificates, and authorities will lock in your security posture for years, just like the foundation of a building locks in its shape and height. If that foundation is weak or badly scoped, everything built on top of it becomes fragile. Your apps, your cloud services, even your zero trust program. We'll approach PKI not as a narrow technical project, but as a strategic architecture and a business risk decision. What you centralize, what you delegate, what you automate, and what you're prepared to own when something breaks. Zero trust is built on a simple idea. Never trust by default, always verify. Cryptography is what makes that verification possible at scale. Digital certificates turn identities into something portable and verifiable. A user, a laptop, an API, even a piece of code can present a certificate to prove who they are. And that proof can be checked automatically using PKI. This is why PKI is often called the backbone of zero trust. If the certificates, keys, or CAs are misconfigured, expired, or compromised, your zero trust policies may look strong on paper, but fail in practice. Throughout this course, we'll treat PKI as the core identity layer that everything else depends on, not as a niche security tool. When you design or modernize PKI, you're never optimizing just one thing. You're constantly trading off security and control, agility and speed, cost efficiency, and the ability to satisfy auditors and regulators. A legacy mindset usually over-optimizes one axis. Squeezing cost may lead to weak governance and manual, brittle processes. Chasing speed might mean spinning up shadow CAs with almost no oversight. Both approaches look good in the short term, but they erode trust and are painful to scale. What you actually need is a balanced strategy. Enough security and governance to withstand incidents and pass audits. Enough automation and self-service for developers and operations teams to move quickly. And a cost model that still works when you extend PKI to multi-cloud, IoT, or new acquisitions. As we move through the material, keep this tension in mind. Every PKI design decision nudges you towards one of these extremes. The goal is not perfection on a single axis, but a deliberate, well-governed balance that supports your business over the long term. At some point, every organization hits the same fork in the road with PKI. Do we build our own CA, or do we buy a managed service? Building internally is about control and sovereignty. You own the root, you define the policies, and you decide how keys are generated, stored, and audited. That gives you maximum assurance, but it also means you own every outage, every compliance requirement, and every 24/7 operational headache. Buying a managed PKI shifts the focus to ease and scale. The provider takes on uptime, automation, and much of the compliance and lifecycle plumbing. You move faster, but accept less direct control over keys, processes, and roadmap. In practice, many mature enterprises land in a hybrid model. Internal routes for ultimate trust and governance, with external or managed issuers for day-to-day certificate issuance. As we go deeper, keep asking, for our risk profile and skills, where do we truly need sovereignty? And where does it make sense to offload? When organizations decide to build their own PKI, the strongest arguments are sovereignty and control. You fully own the root of trust, the keys, and the policies. That can be critical for governments, defense, and highly regulated industries where data sovereignty and national security rules simply don't allow external CAs or cloud HSMs. A self-built PKI also lets you handle edge cases the big providers don't love. Air-gapped environments, WAT, and industrial control networks and very custom issuance or key ceremony processes with on-prem HSMs. You decide where keys live, who touches them, and exactly how ceremonies are run. The trade-off is operational. Once you own the trust anchor, you also own the 24/7 reliability burden. A build choice only makes sense if you have mature operations teams, strong change management, and the patience to run PKI like a critical production service, not a side project. On the other side of that decision is buying PKI as a managed service. Buying is usually about speed and global reach. A mature cloud PKI lets you plug into native cloud and SaaS platforms through APIs, so teams can issue and manage certificates quickly, instead of spending months standing up hardware, policies, and processes. You also get scale almost for free. The provider handles global high availability, redundancy, and performance tuning, so your certificates keep working across regions, without you running complex infrastructure. People are another major factor. Running a secure CA around the clock needs specialized staff with deep crypto and operations skills. Offloading that to a vendor frees your team to focus on using PKI to secure systems, not on babysitting the plumbing. The financial model changes as well. Instead of large upfront capital spent on HSMs, servers, and data centers, you move to an operating expense, a predictable service fee tied to usage. For many organizations, that combination of agility, scale, reduced staffing burden, and OpEx economics makes buy a very strong default for PKI. When organizations budget for PKI, they usually look at the obvious costs first. Hardware security modules, server infrastructure, and software licenses. Those numbers are visible, easy to quote, and tend to dominate early conversations. The real cost of ownership, though, sits below the surface. To run PKI safely, you need specialized staff who understand cryptography, operations, and compliance. You need ongoing training, because standards and threats keep changing. You have to fund regular audits and assessments, especially if you want external trust or must meet regulations like Web Trust or eIDAS. There are also costs you only feel when something goes wrong. Incident response, when certificates break production. Outage impact when an expiry is missed. And physical security for facilities that protect your root keys. So when you think about PKI economics, don't frame it as a one-time technology purchase. Total cost of ownership is the sum of technology, people, and process. If any one of those is underfunded, the others can't compensate, and your cheap PKI quickly becomes very expensive in risk and downtime. As soon as you move PKI into cloud and large enterprise environments, the main challenge is scale, not math. You're no longer issuing a few server certificates. You're managing millions of identities across containers, services, and devices, all rotating frequently. To handle this, you separate the stable PKI core from horizontally scalable issuing CAs. Those issuing CAs are then driven entirely by automation. CT pipelines for services, Acme for web and internal workloads, and management APIs or MDM systems for users and devices. Short-lived certificates become the default, which means renewals must be automatic and invisible to humans. The real design goal is consistency. The same issuance rules, key standards, and auditability. Whether the workload runs in AWS, Azure, GCP, or on-prem. Get this architecture right, and PKI stops being a bottleneck. It becomes an always-on utility that can grow with your cloud footprint. PKI only works when responsibility around it is crystal clear. Think of it as a hierarchy. At the base are the written policies, the certificate policy, and the certification practice statement. These documents codify the rules, what algorithms and key sizes are allowed, how identities are vetted, how revocation works, and what good enough security means for your organization. Above that sits a governance body. This cross-functional group interprets risk, approves those policies, defines detailed standards, and demands audits and evidence. They translate business and regulatory needs into concrete PKI requirements. At the top is executive sponsorship. Senior leaders own the business risk, provide budget and political backing, and ensure PKI aligns with strategy rather than being a side project of the security team. When these three layers work together, PKI becomes a controlled trust system. When they don't, PKI is just cryptography waiting to fail in production. In a real PKI, the biggest risks often come from confusion about who owns what. Operations and security both touch the PKI, but they have very different responsibilities. Operations is focused on keeping the platform alive and healthy. Systems are up, patched, configured correctly, monitored, and backed up. If the CA or HSM cluster goes down at 2 a.m., they're the ones waking up. Security is focused on protecting trust, managing HSMs, running key ceremonies, enforcing policy, and reviewing audit logs. If a key is mishandled or a control is bypassed, they are accountable. The glue between these groups is a clear SLA and a RACI matrix. That's where you explicitly define who is responsible, who approves, who is consulted, and who is simply informed for every critical PKI activity. When this is written down and agreed, outages drop. Key material is handled correctly, and you avoid the classic "I thought they were doing it" failures that bring PKI to a halt. Key management is never a one-time event. It's a continuous life cycle. Think of every private key passing through 4 critical phases: generate, protect, rotate, and destroy. Generation is where security starts. Keys must be created with strong randomness and ideally inside secure hardware like an HSM or trusted enclave, so the private key is never exposed in plain text. Once a key exists, protection becomes the primary goal. That means strict access control, strong authentication for administrators, network isolation, and often split knowledge or dual control, so no single person can misuse the key. Over time, even a well-protected key becomes risky. Algorithms get weaker, software gets patched, and people change roles. Rotation addresses this by regularly renewing certificates and replacing keys, preferably in an automated way so you don't depend on calendar reminders or manual effort. Finally, keys must be destroyed safely. That includes secure deletion from all backups and devices, and revoking any associated certificates, so no one can rely on them anymore. Across all 4 phases, keep crypto agility in mind. Design your lifecycle so you can change algorithms and key sizes quickly, which will be essential as we move toward post-quantum cryptography. When a PKI incident happens, you need to think in terms of blast radius. At the center is the compromise itself. Maybe a key is stolen, a CA is misused, or certificates are misissued. Your first job is revocation and containment. Which keys and certs must be killed immediately, and how you prevent new, unsafe issuance. Once the immediate fire is under control, you move to forensics and root cause analysis. You're not just asking what broke, but how far did trust actually extend? And what assumptions were wrong in our design or operations? That determines whether this is a local problem or a systemic PKI weakness. Next come the outer rings: stakeholders, regulators, and browser or root programs. For many organizations, contracts and industry rules define strict notification timelines and evidence expectations. If those are unclear, you carry far more legal and reputational risk than you think. This is why mature PKI programs maintain specific incident playbooks for misissuance, for CA compromise, and for outages. Each one predefines roles, decision thresholds, and communication paths. In PKI, you're not just restoring uptime, you're reestablishing trust. And the longer you take, the larger that blast radius becomes. When you design PKI today, you're really choosing where your trust anchors and issuing CAs live, and that choice affects control, cost, and speed. An internal-centric model keeps everything on premises. Root and issuing CAs are owned and operated by you. This is attractive for highly regulated environments that need strict control, custom policies, and tight integration with existing data centers. But it demands strong internal expertise and operational maturity. A hybrid model keeps the root or policy CA under your control, usually on-prem, and pushes issuing CAs into a managed cloud service. You still own the ultimate trust anchor while offloading day-to-day issuance, scaling, and availability. This is the pattern most enterprises are moving to, because it balances governance with agility. A service-centric model moves both root and issuing CAs into the cloud. You gain speed, global scalability, and PKI as a service, but you also take on vendor lock-in and must be comfortable with a third party operating your highest trust components. In practice, many zero trust and cloud native programs start here, then introduce a hybrid route when governance requirements increase. By this point, you're no longer asking whether you need PKI or zero trust. You're deciding how to implement them in a way that's realistic for your organization. Start by being explicit about your 3 to 5 year security objectives. What exactly should PKI enable? Strong device identity, passwordless access, secure APIs, regulated signing? Those goals will drive every design choice. Next, choose your operating model. For each trust boundary, decide what must be under your direct control and what can be consumed as a managed service. Many enterprises end up with a hybrid approach, a tightly controlled internal PKI plus one or more external providers. Then assign ownership for risk. Governance teams define policy. Operations teams run the infrastructure. Incident owners handle outages and compromise scenarios. Spell this out early so there's no ambiguity when something breaks. Finally, move in phases. Start with a contained but high-value pilot, often a critical app, VPN, or developer platform. Prove reliability, tune processes, and only then scale to wider use cases. A deliberate roadmap like this keeps PKI aligned with zero trust, while avoiding a big bang rollout that's hard to control.